Good morning. I will quickly run through two types of examples that should help you do all the work for today. So for this one, if I have 10 grams of calcium carbide, I want to know how much of this ethine gas I produce. So it's just a simple mole calculation. So if this is the mass of the calcium carbide, solid calcium carbide I have, then the moles is going to be 10 divided by the MR, which is going to be 40.08 plus 2 times 12.01. So I can quickly work out the moles of that, which will be 40.08 plus 12.01 plus 12.01. 10 divided by that gives me 0.156 moles. 0.156 moles. It's a simple one-to-one ratio, so if I have 0.156 moles of that, I have 0.156 moles of that. Okay, and now the only new bit is that this is a gas, so I want to work out the volume. If you are given data for the conditions, for example, if you're given the temperature is 20 degrees C and the pressure is 100 kilopascals, then you just go straight ahead and you use PV equals nRT in order to do that. You might also be told that it is at STP, in which case you use 22.7 decimeters cubed per mole, or you might be told it's SATP, in which case you use 24 decimeters cubed per mole. It's more likely, obviously, for the IB that they're going to ask you STP 22.7. So I feel like that's a pretty straightforward question. You would just do 0.156. Oh, sorry. So for this, you would have to put it into PV as nRT because this is not an STP temperature. So you would just do V equals nRT over P. Your N is here. Your R, you know from the data booklet. T convert into Kelvin. P convert into pascals, and then your V comes out as meters cubed. So just remember, that's Kelvin, that's pascals, and your V comes out as meters cubed. Okay, so that's your first type of question that you might come across. The second type of question that you might come across will look like this. Now this one I'm going to just describe in a little bit more detail. So if I had 16.05 grams of methane and I want to know how much oxygen I need to react with it, because I've given this as a mass, I can just do N equals 16.05, my mass, divided by the MR, which I've chosen nicely to be the same. So that gives me 1 mole. Now, 1 mole of this will react with 2 moles of that. So at this point you might think to yourself, well, I asked how much of this, how much is a bit of a vague term. You might be thinking, well, the mass of oxygen is going to be the moles times the molar mass, so it's going to be 2 times 32 equals 64 grams. However, it's very unlikely in the real world that you're going to be dealing with masses of gases. Generally, we don't use mass as a quantity for a gas. We use volume as a quantity for gas. So we might think to ourselves, well, if I've got one, let's do this all at STP, okay, which means that 1 mole equals 22.7 decimeters cubed. So it's more likely that rather than say 16.05 grams of methane, that I'm going to say 22.7 decimeters cubed of methane, because that 22.7 decimeters cubed has a mass of 16.05, and the reason I know that is because both of these are 1 mole. So if this is 1 mole of this gas, then 2 moles of this gas is going to be 2 times 22.7, which is 45.4. So this is going to give me 45.4 decimeters cubed of oxygen. Now, what's happened there is I can go to the moles and use the moles 1 to 2 and then work out the volume 1 to 2, or I could just treat this number directly as a number of moles and just double this. So for example, if I had 100 decimeters cubed, I could, if I want to, convert this into a moles, then do the 1 to 2 ratio and then convert the moles into a volume. Okay, we can do that. So I know that 100 divided by 22.7 is going to give me my number of moles. So that's 4.405. So N here is 4.405. And if that's that number of moles, then, and this is twice as many, then I'm going to have 8.810. N equals 8.810. And I can convert that back into a into a volume. Okay? Because if 1 mole is 22.7, then 8.810 is going to be, oh, look at that, 200. What a surprise. So the point that I'm trying to make here is that when you're dealing with volumes of gases, you just treat this volume directly as a mole quantity. So I don't need to do it at all. So if I had 2 centimeters cubed of methane, I would need 4 centimeters cubed of oxygen. I don't need to do the mole part at all. Now the reason for that, the reason it works is because Avogadro's law. Remember, which says that N varies with V, right? Or same volumes of different gases contain same number of moles. And what this means is that because N is proportional to V, I can use V as a sort of proxy for N. I don't need to do the conversion because they're all relative. So if you ever see a question and it tells you the conditions don't change and you're given a volume, you just go ahead and treat the volume as a number of moles.